Howdy folks. So we are getting into section 10.1 now, final push here for our pre-algebra course. So this first section is going to get into the product rule and power rules for exponents. So just a little bit of a refresher here that if we have something with exponents such as 2 times 2 times 2, we can write that as 2 to the 4th power, which is 16. So if we expand this idea, then if we multiply constants or variables with exponents that have the same base, so again, they're very important that they have the same base, then we simply add the exponents and keep the base the same. So just to kind of see that in action here, if we got 2 to the 3rd power times 2 to the 4th power, we can break this down a couple of different ways. One of them would be to just expand this out. If we use parentheses, we can write 2 to the 3rd power like this, 2 times 2 times 2. And what we want to do is just multiply that by 4 more 2's. And so now we can see if we just remove the parentheses, then this will be equal to 2 to the 7th power. So that's the long way to think of it though. The short way is based on what we just set up here. Because those bases are the same, we can just add these two exponents together and we can see that we get 2 to the 3 plus 4. And so that 3 plus 4 gives us our 7. So that's going to be the easier way and the way we want to do these problems. So this describes the product rule for exponents. So anytime we have two things with the same base, so we can see that A is our base for this rule, and we have M for one exponent, N for the other, we can just add those two exponents together. Pretty quick. So let's just do a few problems to make sure we have it down. So if we have 3 to the 6th times 3 to the 5th, so we know that this is going to be 3 to the 6th plus 5, which would be 3 to the 11th. And we can just rock these out pretty quick. So x to the 7 plus 12, which would be x to the 19th. Now this next one is a little bit trickier just because, well, we have an exponent on the first one, but we don't have an exponent on the second one, or do we? And in fact, we do have an exponent on the second one. Even though there's not one written here, we can put a 1 in and it doesn't change the value of that. Just like if we put a 1 in front, it doesn't change the value. Same thing for the exponent. So using this now, we can see that we have y to the 5th plus 1, which would be y to the 6th. All right, and now let's try 3 of them stacked together. Z to 2nd times z to the 5th times, or 4th times z to the 5th. So we can just do a chain addition and we get z to the 11th power. All right, so hopefully so far so good. Let's see if we can trip you up a little bit. If we got 4 to the 2nd times 5 to the 3rd, how are we going to tackle that? Now, some of you might say, well, this should just be equal to 20 to the 5th, right? That is a big no-no. That's not correct. The reason why is because our bases aren't the same. So because you have a 4 for one base and a 5 for the other one, we can't combine these at all. So this is going to just stay 4 to the 2nd times 5 to the 3rd. All right. Now this next one is a little bit different because now we have a coefficient to our variable and we have another coefficient of 7 for this variable term. So how do we tackle that? Now because these coefficients are not impacted by exponents, we can multiply those. So 8 times 7 is 56. But now we can apply our product rule to the r's. So we got r to the 3rd and r to the 4th. So that better be r to the 7th. All right, what about this next one? So now we have a -6 coefficient, we have an 8 coefficient, and then we got some p's with exponents. So what do you think for that one? Well, we can again combine our coefficients by multiplying. So -48, and now we got p to the 5th and p to the 12th. So if we add those exponents, we should get 17. And now what about this last one? Well, this one is a little different because now we have an exponent that's outside of the parentheses. These last couple of problems, well, at least this one here, we had exponents inside the parentheses. So we have to be careful how we interpret this one. So let's hold this and let's explain it down here. One of the ways we can break this down is just like we did originally and expand it out. So because this x to the 6 is inside the parentheses, we can think of that whole thing as the base. And they want you to take that base and multiply it by itself 3 times. So you got x to the 6 times x to the 6 times x to the 6. But now that it's in this format, we can use our product rule. And so we can write this as x to the 6 plus 6 plus 6, which is x to the 18th. So now can you see the trick? How do we get from here to here? And you're probably guessing it. We want to multiply those exponents. So if we multiply 6 times 3, that'll get us our x to the 18th power. So that is now describing the power rule for exponents. Now there's going to be a couple of layers to the power rule, but this is the first layer and probably the most important one. So anytime you have something with an exponent inside with an exponent on the outside of the parentheses, we're always going to be multiplying those together. So let's try this one out. So for this first one, we got 4 to the 3rd on the inside and exponent of 2 on the outside. So you should be able to see that that is 4 to the 3rd times 2, which would be 4 to the 6. So now we got t to the 4th, all raised to the 5th. So same idea. T to the 4 times 5, which is t to the 20th. And now we got another stumper. xy with no exponents raised to the 3rd power. Well, let's apply the same ideas that we did in the previous one. So same tactics. Let's instead expand it out and see if we can find a pattern. So we should be able to see that this is going to be xy times xy times xy. Well, let's rearrange it a little bit. If we kind of separate everything out and put all of our x's together and then put all of our y's together, it's going to look something like that. And now let's put those exponents back in. So we got x to the 3rd, y to the 3rd. So you can kind of see that if we took this exponent on the outside and distributed it in to each of those variables, think of each of these variables as having a 1 for an exponent. And if you distribute that 3 in, we'll get this result. So that is another layer to the power rule. So if we have something like this with an exponent on the outside, we can distribute it to each variable on the inside. And it doesn't have to be a variable. It could be a constant or a coefficient. So take, for example, our first one, 7r, all raised to the 3rd power. So if we distribute that 3 in, you should see we get 7 to the 3rd, r to the 3rd. Now, can we simplify that down a little bit more? Sure. If we wanted to simplify 7 to the 3rd, we could get a single value for that. So remember, 7 times 7 times 7, which better be 342, or excuse me, 343 to the third power. So either one of those would be acceptable. Now, when you're using MyLab Math, make sure you follow the directions and write your answer as they indicate. Otherwise, they might mark you wrong. So what about this next one? 5xy all on inside of the parentheses, and we got a 5 for an exponent on the outside. Well, you do want to do the same step. You want to distribute it to all three of those things. So 5 to the 5th, x to the 5th, and y to the 5th. Now 5 to the 5th power is going to start to get a little bit bigger, but if you did want to multiply that all out, you could. And just to be safe, let's use a calculator to do that. So if we said 5 times 5 times 5 times 5 times 5, 3125. So either one of these would be acceptable in my book. All right, so far so good. Let's try one with a negative in there. So we have a negative 2, x to the second, y, all in parentheses, raised to the third power. Now, when you start to have those exponents on the inside, remember what we did before with the first layer of the power rule. When we had an exponent on the inside and one on the outside, what did we do with them? We had to multiply them. Same thing here. Now, because we have a negative number, I'm going to put it in parentheses. It's just because we want to make sure we include that negative when we apply the exponent. So if we take our 2 times the 3, that's going to give us a 6. And then we got our y to the third. And now anytime we have a number raised to a power, we can simplify it down a little bit more. So I would also take negative 8, x to the 6, y to the third. All right, let's try a couple more, and then we'll pause the video for the last little bit. So we got 3a to the third, b to the second, all in parentheses, raised to the second power. So again, distribute that to all three pieces. So that 3 is going to get the exponent of 2, a to the third, but we got to multiply it. So it's going to be a to the 6, b to the second, again, multiplied by the 2, so b to the 4th. And the other rewrite for it, 9a to the 6, b to the 4th. Now, this last one, now we have a fraction. So this one's a little bit different, but let's do what we've done when we weren't sure what to do. Let's expand it. So this should be a half times a half times a half. Now, if we wanted to, we could separate all the tops and all the bottoms into a single fraction. But now, write that with exponents. 1 to the third over 2 to the third. And we could go a little bit further if we wanted to and say that that is going to be 1/8. But look at the way it is affected. So very similar to what we saw before. We have to distribute it in, but now we just have to distribute it to the top and the bottom. Very important to do to both. So that's going to give us the third layer of our power rule. And I think we're going to push through and try to get all of this in one video. Might be a little long, but that's okay. So the last layer of our power rule, exponent is on the outside and we have a fraction on the inside. It's got to go to both, top and the bottom. Now we've already did this problem, so I don't know why I have it twice, but let's just cross that out. So let's jump to B. 9 over 8, all raised to the 5th. Pretty cut and dry, right? 9 to the 5th over 8 to the 5th. Done. Now what about xy over z all raised to the fourth power. So what do you think about that one? Now you could do this in a couple of layers, but hopefully you're starting to get the idea that it's got to be distributed to every single little piece inside of those parentheses. So the x is going to get the exponent, the y is going to get the exponent, and the z is going to get the exponent. All of them will be raised to the fourth power. And to finish it off, let's look at this last one. A to the second, b to the third, all over c to the fourth. So what do you think about that one? Same thing applies. If there's an exponent on the inside and an exponent on the outside, you gotta multiply them. So, since this one has a 2, 2 times 5 is 10, so a to the 10th, b to the 3rd to the 5th. We got to multiply those to b to the 15th. And last but not least, c to the 20th. So hopefully you have a sense of how this rule works. Again, use the advantage of having the exponent outside the parentheses versus inside. If it's inside, usually you're going to be able to add them or something like that. But if it's outside and inside, you're going to want to multiply them. So hopefully that is pretty clear, but if not, make sure you reach out and let me know. I hope to see you in the next video. Take care.